Okay, so I am going to start with this problem. Okay, so it says find the two smallest positive integers that are different, having the remainders 2, 3, and 2 when divided by 3, 5, and 7, respectively. So the first thing that I saw when I was looking at this is I'm looking for a number that has a remainder of 2, 3, and 2. If divided by 3, 5, and 7, respectively. So it was a pretty straightforward question. So there wasn't a whole lot that I had to really think about when I was trying to rewrite the problem. But the first thing that I thought about is it's important to find the pattern and perform kind of a guess and check method until I find a solution that works. So for me, I realized there was a lot of long division, which has been a while since I've done that. So I decided that I would start with the prime numbers because all of the numbers that they were being divided by were prime. So I thought that I would just kind of start with that and see what happened. And it's funny because the first number I tried was actually one of the numbers that worked. So the first number I tried was 23. And as you can see right here, I can't make any marks on this, but on this right here, 23 divided by 3 equals 7, remainder 2. 23 divided by 5 equals 4, remainder 3. And 23 divided by 7 equals 3, remainder 2. So that one works. And so then to make sure that I didn't miss anyone, I started going back through all of the other numbers. And as you can see, there's some work that I've done here. And I would basically stop as soon as I found one that didn't work. So I tried all of the prime numbers first. And then I just kind of thought about any of the other numbers that I knew. I mean, there's numbers, even numbers obviously wouldn't have worked for this situation. And so I could eliminate almost half the numbers right there. And so then I got through all the numbers and realized that 23 was the smallest. And so I think that was kind of my first strategy for solving the problem. But then I realized pretty quickly that I was going to have to do a whole lot of long division and doing all of these out, and there was a lot faster way I could do it. So I went to my trusty little Excel spreadsheet and I started dividing the numbers. So I went through, as you can see, I started at 24 and I went all the way down to 129 essentially. And so then this is the number that was being divided. And then there's this thing called the mod calculation right here. And so basically what it does is it will divide numbers for you. And then what will be computed in the index or in the cells is going to be the remainder. So for example, 24 divided by 3 is, I just took let me do this one. 25 divided by 3 is, has a remainder of 1. 25 divided by 5 has a remainder of 0. And 25 divided by 7 has a remainder of 4. So that's kind of the pattern. So then I just looked at all these numbers and waited until I got to all the way down to 128 before I found the pattern that I was looking for. So that's how I found the second number, which is 128. So kind of like I said, at the beginning of the problem, I got pretty lucky to find the one that I needed. However, it wasn't until I got through a bunch of numbers that I realized there's a lot easier way to do this. And so then I just plugged them all into the Excel spreadsheet and made it a whole lot simpler. Okay, so now I'm going to go to this problem. If Uzbek currency consists of a 13-cent and 17-cent coins, can you buy a 20-cent newspaper and receive exact change? So the way I kind of wanted to rewrite this question is how much money in 13 and 17-cent coins do I need to pay with an order to get exact change? So the first thing that I wanted to do was figure out the relationship between 13 and 17 and see if I could use that information to figure out how many coins that I was going to need in order to figure out exact change. So the first step I discovered was that 17 minus 13 equals 4, and 4 is an exact, if you multiply it by 5, you're going to get 20. And so thinking about that, I was like, okay, well, maybe if I pay in 5, didn't mean to do that. If I pay with 5 17-cent coins, that would equal 85 cents. And so if I gave him that, then I would get 65 cents back, which is a number that is divisible by 13. And so I would get 5 13-cent coins back. So I kind of did the math right here. So 17 minus 13 equals 4. And then 4 times 5 equals 20. And 17 times 5 equals 85. And then 85 minus 20 equals 65. And then 65 divided by 13 equals 5. Now, this is just one of the solutions that I found, and it definitely is possible. However, I do think that the nature of this problem would probably indicate that there are multiple solutions and ways to solve this problem. But this is how I solved it. And I didn't really change my strategy any from when I started. I just kind of thought that I would try this way and see if I found the answer that I was looking for, and just used simple subtraction, multiplication, and more subtraction. And yeah, that's pretty much all I did. So yeah, that's it.